Okay, are we all here? Meredith and Nicole, try to unmute yourself, if you would.
Alrighty, hello.
Up at the top, that's okay. You're good? Is that, and Nicole? Let's see. Okay, Nicole, try up at the top.
How about now?
There you go.
There you are.
Excellent.
Okay, 2 people? Excellent. Okay. All right. Hi, everybody. This is Learning Space, CosmoQuest's weekly hangout about astronomy education and outreach. And I am Georgia Bracey. I do formal education with CosmoQuest. And today I'm very happy to have with me 2 wonderful guests, both from the University of New Mexico. I have Meredith Rawls, and I also have Dr. Nicole Vogt, if I said that right. And we'll have you guys tell everybody a little bit about yourselves in just a second. I want to tell everybody out there that you can watch this video on our YouTube channel. You can also look at the CosmoQuest event page and watch us there. You can also comment in both of those places. And you can also comment on Twitter with the hashtag #LearningsPace. And I will do my very best today to try to track people's comments and respond, pass along questions. So please feel free to ask us questions as we go. Make some comments. We have a great program today. We've got a wonderful astronomy learning tool that everybody can take advantage of, so we want to share all that out with you today. So enjoy the show with me today. So let's start with Nicole and Meredith. Nicole, would you like to start? Tell us a little bit about yourself, just briefly, and what your research interests are at the University of New Mexico.
So I'm a member of the extragalactic group at New Mexico State University, which means that I study things beyond our own galaxy, and my focus area is studying the evolution and the formation of galaxies. Oh. So in a nutshell, what I need to do is to understand how stars change and grow over time within galaxies and thus affect the evolution of the galaxies themselves.
Okay, wonderful, wonderful. How did you get interested in that area?
Well, I've always thought extragalactic astronomy was just a heck of a lot more exciting than other fields in astronomy. No offense intended.
I know, it's fascinating. I have to agree.
A lot of other things seem like work, but
really wild stuff.
This was the fun part. I sort of followed telescopes my whole life. When I was a child, I had a chance to go to Palomar Observatory when I was very young, and the weather was so bad that the astronomers on site weren't able to observe. So what we did was we basically grabbed huge pieces of paper, and then we shone the light through the telescope onto a wall, and we went ahead and looked at the moon because they weren't working anyway. So it was a really fun adventure for me as a child, and a way to see exactly how telescopes worked. And then when I graduated from college, Cornell University had just bought a large share of time on the Palomar 5-meter telescope, which at the time was the largest optical telescope in the world. So I landed at Cornell just as this telescope time was all available, and nobody knew what to do with it. So it was a wonderful time to get involved in a large-scale survey, which is something that I did with Martha Haynes there. And then when I started being a postdoc, the Keck telescopes were really coming into their glory. So I jumped into the UC system and started observing a lot of Keck. So in a sense, rather than moving from university to university, I jumped from telescope to telescope.
Excellent. That sounds so bizarre to have lots of telescope time and nobody knows what to do with it.
Yeah, that was a very brief one.
Great. Okay, thanks. Meredith, how about you? Tell us a little bit about yourself and your current interests and what you're doing.
Sure. So I'm a graduate student here at New Mexico State University. I just began my 4th year, I guess it is now. And my main research interest is actually a little different than Nicole's. It's more about stars, and in particular binary stars, or stars that come in pairs. And I got mostly involved with that research a little bit in undergraduate. I went to Harvey Mudd College for my undergraduate. but it really kind of became the direction I was heading when I was at San Diego State getting my master's degree, because my advisor there worked on a really cool kind of binary star called an X-ray binary, where they put out these crazy X-rays, and you can figure out all kinds of interesting things about the two stars by observing them in different kinds of light. So while I haven't really stuck with X-ray binaries per se, currently, that kind of got my interest really in these crazy stars that orbit around each other, kind of going from there. So.
Okay, fantastic. So you're a grad student there, and so you, so both of you are involved in teaching at the university, and Nicole, you're a professor there, and then Meredith, as a graduate student, are you TA? Would that be?
Mm-hmm. Yes.
Correct? Okay, helping out. Good. And you have this wonderful program there, the General Education Astronomy Source, GEAS. How do you say your acronym, or do you just say GEAS? GEAS? Okay, excellent. Another good acronym. Maybe Nicole, tell us a little bit about how this sort of got started, and you can give a quick sort of tell us what it is, but then I'm interested in how it all began.
Okay. So the GAIS project is an umbrella project, and it covers several tools which are designed to increase the availability of astronomy throughout this country at the college level. We provide a library, a self-review library, which allows students to work through problems on their own and get immediate feedback through a very large database of general education astronomy questions. This is something that we provide for students, and we also provide to instructors throughout the country. So let's say you're an instructor working maybe at a community college, you haven't received a lot of support, you don't have a lot of time available to develop your own resources, but you want to offer astronomy at your university. This is a resource that you can use with your own students at your university in order to give them access to the information and to help them work through solving problems. Okay. We also have a set of laboratory exercises which are specifically designed so that they can be conducted by students working on their own at a distance. And this is an area where Meredith has been working very intensively with us. She's the teaching assistant for the class we're teaching this semester, for example. And so she's working a lot with students who are spread throughout this country, and in fact this semester throughout the world, to conduct astronomy observations and analyze data without ever coming face to face with either me or Meredith. So this is a big challenge for us and for our students. Sure. And then a third component of the project is an exercise in outreach for astronomy. And what we've done is to create a series of short films that emphasize the diversity which is already available within the astronomical community. Mm-hmm. We've created a short set of films, and we don't focus on the Stephen Hawkings of the universe. Instead, we've picked out individuals who are contributing to astronomical research, who are in really important positions, but who don't have PhDs, sometimes don't have master's degrees, don't even have bachelor's degrees. Some of our subjects only have an associate's degree, for example, so 2 years of education past college. And what we've tried to show by highlighting the work and the efforts that these people go through on a daily basis is how important their efforts are to the success of modern astronomy. We want to send a message that astronomy is not this tall ivory white tower in the distance where you can't go because you don't belong there, right. But that this is a very accessible field, and that anyone who has an interest in the field and the ability to focus and work hard can be a strong contributor to our field.
And that's a great message. I know personally I always sort of accessed astronomy through amateur astronomy, and we always used to say, that anybody can go out and look at the stars, and you can get a telescope, and you can have access to the night sky. I mean, that's there for everybody. But then to take it a step further and actually be a professional at some level, have some type of career related to astronomy or even STEM, that requires, often another level of commitment and resources, and something like this where you're making this available to people, as you say, all over the world at this point, is fantastic. So where you are in New Mexico, you have a large population that has trouble accessing university education. Is that correct?
This is very true.
Of distance. Can you tell us, and maybe other things too, but yeah, tell us a little bit about the people that are, close to you in a way, but yet still have trouble with access?
So Meredith and I are working at a university which is in the southern end of New Mexico. This is a very rural area. The population is greatly dispersed, by which I mean that our little city of Las Cruces is the big time for a lot of people. We're the largest population center for hundreds of miles. And there are a lot of people who live in West Texas and in New Mexico who aren't able, for a variety of reasons, to come and live within the town and to attend classes on a daily basis. And yet they still need to attain that college degree in order to succeed in their lives. We have people who work on ranches, who work on farms, who have family responsibilities, cultural responsibilities, things that make it difficult for them to come to town. And we also have a large population of people who do live in town but who are unable to sit classes during the normal business hours because they have full-time jobs, children, responsibilities of various types. So we're both trying to serve people who are working at a distance from us and people who are time shifted. One of my early students was, in fact, a watchman at a NASA site in the area. So his quality time for studying was 2 a.m. to 4:30 a.m. Every half an hour, he'd have to get up and walk through the site and check that nothing had exploded, but then in between he would study. So he really needed a resource that would work with him 24 hours a day wherever he was. And that was one of the motivations that we had for creating these resources.
Yeah, the labs in particular can be restricting in the traditional classroom setting, because all of the labs that we offer are in the afternoon on Monday through Thursday. And so if you aren't available in the afternoon, you can't take this class. And I believe it fulfills the NMSU's general education something. What is it called, Nicole?
So there's a general education science requirement.
Right.
A few years ago, the state legislature decided science is very important. So in order to increase the scientific literacy of our population, we're going to double the science requirement to get a bachelor's degree in the state of New Mexico.
But not double the classes offered.
This is a great idea, but we got no new classes, no new staff, no new resources, no new chairs, nothing. And so what we're seeing now at the university is a wave of students coming through who desperately need 2 science courses in order to get the degree, but there's nowhere for them to sit. Right. So we're trying to make the bachelor's degree requirement more accessible to the population that we have throughout the state.
Okay, great. And Meredith, as you said, so a lab portion of a typical class might pose even more of a challenge to do at a distance. So maybe could you tell us a little bit about how you guys work that? How do you get the lab portion of your course out to people who are far away?
Sure. So that's probably been, at least from my perspective, the most challenging piece of this. I actually got to work with Nicole my very first year here. She was doing some piloting of the labs that she'd been developing with her team that are now full versions of the labs that we do with our students at a distance. And so what we have them do is they have to use common household materials like a measuring tape and like a piece of cardboard and hopefully some scissors if they can scrounge that up, thread, things like that that most people either have or can easily borrow. Or buy for not a lot of money, like a bag of marshmallows. We have them use for one set of experiments, and we provide them with really detailed instructions of, look, you need to go outside and you need to throw these marshmallows and you need to measure how far they go. And it sounds kind of silly, but it gets them a nice introduction in that particular case to the idea of statistics and a normal distribution and an error bar. And even though I am throwing as consistently as I can, I'm not always going to throw the exact same distance. Try though I might. Things like that. So implementing this is a bit challenging, though, especially at the beginning of the semester when students might be thinking, oh, well, this is an online class. I'll get my science requirement. This won't be a problem. I'll just log on every week and type a sentence and I'll get an A. And then we're like, no, this is an actual time commitment. You need to read this long PDF that has detailed instructions in layman's plain language. We're not trying to be all technical on them, but we do introduce some mathematical concepts that they'll need throughout the semester. Nothing crazy, no calculus or anything, but calculating an average, reading a graph. And then they have to log on to Google actually and use the Google Drive, Google Documents, to share a lab report with us that we can then see and edit in real time as they upload their answers to the lab as they work. And so ideally we can see like, oh, okay, you've taken 2 sets of data so far, and they were slightly different. You need to take 5 more sets of data, and then you'll make a graph. And if you make your graph with the wrong axis label, I can comment and be like, were you measuring in feet or inches or whatever the case may be. And they can get the kind of real-time interaction through that commenting system instead of through actually being in the same room as us.
Okay, so Google Drive and Google Docs is a big part of how you are doing that back and forth interaction.
Yeah, it's been really helpful.
Yeah, great. Is the technology at all an issue for some of the students? So obviously they need internet access. Google, is there anything that sometimes gives them particular challenges?
So internet access is
the
key thing for our students. That's something we emphasize at the beginning of the course to let people know that they have to have that. If you look at the statistics for modern college students, you see that 95% of students, this is amazing to me, 95% of college students today have reasonable speed internet access at home, and 100% have it somewhere in their lives right now. So we're targeting a population of people for whom the internet is becoming more and more a way of life. We have students who work in cities, who work from home frequently. We also have students who will go to a library, either a university library or a public library, because these days we often see public libraries being a site for internet access, or sometimes a cafe. But there are various problems. Sometimes Meredith and I will end up with an email from a student that says, sorry, I missed last night's deadline. The goat ate my internet. And it turns out that the wiring was consumed by a pesky goat, and so the ranch gets cut off for 48 hours, fixes have to be made. So some of the problems we face are unique to the distance ed regime. One of the things we do when we develop these lab resources is we field test things with students on campus first. So when we were developing lab exercises, we spent a lot of time watching our in-class students, looking to see what they did, where they got stuck, what concepts were most troubling for them. And then for each lab, we build a video tutorial that goes along with the lab. So you've heard the expression that a picture is worth 1,000 words, and in this case, a video can be worth 1,000 pictures, because it is literally 1,000 pictures. So when students have to build a piece of equipment, say construct their own sextant so that they can measure angles on the sky, we show them video of someone putting the same sextant together and then using it to look at the moon on the sky, for example, so that if they have difficulty working with the text in the lab chapter, they can see someone modeling the exact behavior that we have. We also have skits that are recreated by students and shown in the tutorials, where students walk through the kind of puzzling problems that come up in these labs, and they argue different sides of problems, and then they try and resolve things by applying the scientific method. So we're trying to provide a combination of resources available through the internet, and then the interactivity that Meredith mentioned, where when students work on a lab exercise, they don't just do it for 2 weeks, turn it in, and find out what their grade is, but instead they're going back and forth with us on a daily basis so that we can work out the little stumbles that occur through the process.
Sure.
This is particularly important to us because so many of our students have never actually performed an experiment of any type in their lives. They don't have the concept of performing an experiment, and they definitely don't have the idea that this is an arena in which they are entitled to move. So we need to convince them that this is something for them, not just for the scientists in the ivory tower.
Sure. Now, is that something that they can go into? You have this big review component, that library component to your project. Do you often send them there with particular things to go
Absolutely.
on, or how does that work? Is that something, do you find out a little bit about your students when they first come into class and then make some recommendations, things like that?
We survey our students at the beginning of the semester to find out what their background is in math and the sciences, and also any limitations, like where they're living, how good their internet connection will be, what sorts of physical limitations might come into play in the class. And then students every week work through problems. So rather than, for example, a more English or history-based curriculum where you might do lots and lots of reading and then critique those texts, for example, we emphasize the art of problem solving. So we want our students to solve new problems by seeing initial problems solved for them. And so this is brand new territory for a lot of our students. They're simply not comfortable with the idea of learning by working things out for themselves. one of the things that our database has is a very complicated back end which provides to instructors a detailed view of what students are doing. So if we have a student who, say, stumbles in at 3 a.m. after being at the bar on Thursday night, none of my students would ever do this, but maybe some others would do this. And then, they take quizzes from 3 a.m. to 4:30 a.m. in the morning, and they spend half the time that everyone else spends on the questions, and they're scoring about 20% success. We see that in the record. Every quiz that a student takes, every problem that a student solves is recreated in the library. And so the instructor can go in there and look at that student's record. They can see every problem that a student solves, and they see the wrong answer that the student submitted as well as what they were shooting for. So, for example, if a student is consistently off by a factor of 100 when we're covering units conversions because they've mixed up centimeters and meters, we see it, and it's something that we can work with them to fix. So we're constantly looking for patterns in the material that they're addressing. And there's a lot of interplay between the laboratory exercises and the material in the database. So one of our most challenging concepts for students is the idea of visualizing the moon going around the Earth and the position relative to the sun, and how this creates the phases that you see, and also gives you the predictive power to know exactly where the moon will be in the sky at any time. This is something we're wrestling with this week, in fact, and the big disaster for us, as Meredith is wincing in sympathy, is the weather that we've been facing. Yeah. So to try and support the lack of physical observations that we hit for a few very bad days, we had students working with video tutorials, looking at physical animations of the movement. So you can either place yourself with the God view above the North Pole of the Earth and watch the movement of the moon around the Earth, or you can place yourself on the surface of the Earth and see the sky moving from side to side. And you can do all these things, and then when you can get real data of your own by observing the moon and looking at the angle made between the moon and the Earth and the sun and the sky, somehow a consistent picture starts to emerge for students. And the key here is visualization, a grossly underrated skill which people frequently haven't used before. So we really try and immerse them in things and work both on the lab side of the course and the self-review library side of the course simultaneously on our key concepts. The other thing we do is that we have a math review of all the math that you need for the course, which occurs in the second week. This is rather bracing for a lot of students, but we tell them, this is the math. If you can get through this, if you can do these problems, you can do any math problem in the course. And the reason we do that is so that we can really evaluate their math skills and see where there are holes, where there are strengths, and understand what the most challenging problems will be for them.
Okay. Good. And then I know you hold office hours, correct? So as you go through the course, you have, do you require students to meet with the two of you online at all?
We don't require it. Students,
as needed, you're just available at certain times?
Yes, they can choose the venue they're most comfortable with. So some students work via video chat, just like we're doing here today. Others, it's email, and then a lot of the others will write lots of comments in their lab reports, and we go back and forth.
Yeah, we try to accommodate whatever works for the students, because their timetables can be crazy, right? Like I try to keep my work to kind of vaguely normal working hours, but then it becomes apparent that, well, they also have jobs and other school classes or whatever. And so last night, actually, I held a virtual office hours using Google Hangouts for about an hour at 8:30. But we only had one student, actually. But that one student was very glad that we did that. We were able to answer all his questions. Just about as effectively as you could if you'd actually, schlepped all the way to my office.
Right, right. Oh, that's fantastic. That's great. So do you ever have the students work with each other? Is there ways or opportunities for, group work or at least some discussion back and forth, things like that?
That's something we build into the course in the early weeks because we'd like to forge study partnerships for students. It's, of course, a challenge for them because they might be teamed up with someone who's not even in the same state, let alone the same time zone. Mm-hmm. But in our initial lab exercises, we have students perform a simple experiment, like the one Meredith described, where you throw marshmallows as far as you can, and then you look at the distribution. And then they have a partner who has done a similar but different experiment. So one student might throw marshmallows, another might measure the size of tortilla chips. The two students then have to submit a description of their experiment blindly. So they get a page to describe their experiment. They give that to the partner, who then has to attempt to reproduce the experiment with no clues, no backsies, no chances to ask questions, as a way of teaching them how important communication is. And then once the two students have done each other's experiments, they have to get together. And the key question they have to answer is, have we successfully reproduced the same experiment? Or are the differences between the properties too different? Was there a substantial change between the experimental setups? So this gets the students talking to each other. It's helpful because they then realize that they're not the only person in the class who feels a little uncertain, a little confused about things, so they get to share. And one of our hopes is that by setting up these partnerships early in the semester, people will continue to work with that student and to reach out with that student when they'd like peer contact. One of the critical limitations of this whole distance education science project is, of course, that we lose the peer group in the lab. When Meredith and I work in the classroom, we have students often working in groups of 4, and they'll do their lab exercises in groups of 4. So there's a lot of peer-to-peer support and communication that goes on, which augments that with the instructors, and in some cases is a lot more useful. We tend to come through with the theoretical model, the big picture, you know, the overview, and sometimes the student just wants to lean over and say, hey, you needed to divide by 2. So they like to, you know, get back to the concrete things of what's wrong with this question on this page. And so that's something that it's very difficult to recreate in the distance module.
Okay, good. And Meredith, tell us a little bit about your role as TA for all of this. What kinds of things do you do to work with the students through the semester?
So I mostly help them wrestle with the labs. If they have questions about the lab,
right?
I try to be one of the first of us to respond to their questions in the lab. Sometimes Nicole beats me to it, depending on the time of day. But if they have comments in their lab, I'll try to answer them, or questions or comments, I'll try to answer them. If they haven't done anything, I'll send them a message and be like, you should probably do something. Things like that. Also, if they are just like, I have no idea what to do, then I will point them in the direction of some of the class resources, like the video in particular that Nicole talked about, which gives a nice overview of actually another person doing what you're supposed to do, which is a lot more instructive than just, hey, read this 20-page PDF that you already tried to read, right? Yeah. And I also set up meetings with students. Occasionally we do have some students who enroll in this course who actually attend the campus here at NMSU. And so sometimes I'll actually set up, okay, would you like to meet in my actual office like a normal student TA thing? And so, because sometimes for some students that really is the best option, if it is an option. And so I've had a few meetings like that with students where they'll come and like, look, I'm trying to get the hang of this course. I understand that there's these Google Documents, there's these videos, there's this chat room thing, there's all these different resources. Like, what am I supposed to do by Friday? And so we sit down and we're like, okay, so do you have this part under, we just kind of go through and make sure that they feel comfortable with all the resources that the course needs them to pull together. And I also grade the labs, which is probably the most tedious part, because at the end of all of this lovely interaction, I do have to actually give them a grade. Right. So grading with Google Documents is a bit of a odd challenge. I'd be interested to know if any other classrooms are using Google Documents as a way to submit assignments, because as far as I know, there's no way to really be like, okay, you may no longer edit your document. It is the deadline. I shall now commence grading. There's no real,
kind of freeze
stop
it
button. Right. I mean, I could download my own copy and save it and whatever, but I find it's easier to just go through like the next day, and if they squeak in at 3 in the morning and add the last sentence they were frantically trying to type, I don't really care.
Yeah, that's a good question. I don't know. I know there's lots of other people out there that, especially, I'm more familiar really with K-12, and I know there's lots of teachers that use Google Docs all the time, but I don't know that answer to that particular question, but maybe somebody does know and can comment on that or put it on our event page and somehow get the word out about that. That's a good question. So, all right, so how many students do you guys actually have in one semester typically for this course?
We have 26 students right now.
Okay.
And that's really on the high end of what the two of us can handle through a semester because of the huge amount of interactivity that is required to get students.
It's just the two of you, then no other TAs or
Just us.
Okay.
Because for a quote-unquote normal lab, again, the students would work in groups, right? And we might have them submit one lab packet as a group, and so the grading in particular would take less time. But when every single student, ideally, has their own lab report, it takes my entire huge monitor, I open them all up and try to see what everyone's done in some kind of finite time.
Yeah. So. Okay, so about 26 students. And you mentioned you have students from all over the world at this. Is that new for this semester? That you have some international students?
Well, we have our New Mexico State students who are leaping all over the place. Often we'll find someone who started a degree at New Mexico State in residence a few years ago, maybe a decade ago, and then for whatever reason, family, work, responsibilities had to stop completion of the bachelor's degree, and then they move away.
Okay.
So I've had an internet security consultant who worked out of Washington State. This semester we have a CBS cameraman, so this has been very interesting because we get his feedback on what's going on with the storms on the East Coast. We also have a college-age student who's working out of Europe and will be moving to South America next week to continue her work. So people are really living their real lives as they complete this course.
Okay. So
a lot of our students, however, are based in the Las Cruces area within 100 miles of the campus and simply need to be able to flex either in time or in space.
It's just a flexible option. Yeah, that's great. Do you find that a lot of students sort of have the misconception that the online course will be an easier course or take less time, or, I mean, just get into trouble sort of that way just because I think that's a common misconception, and you can probably speak to teaching an online course as well. I think a lot of teachers have the misconception that having an online course might be somehow easier than actually teaching in the classroom. But so maybe coming from both views, what do you guys see from your students and from your own experience?
I can tell you that teaching this course with a group of 26 takes much more time than teaching a group of 85 in the classroom. The amount of interactivity that is required is tremendously large. And we also frequently have people who have been out of the college level education process for a number of years, and there's a lot of remedial work that hasn't been done. And so we need them to cover a lot of ground very quickly in order to be able to appreciate the scientific and mathematical topics that are covered in the course. So that's a real challenge for them. We've also discovered the hard way that the student expectation is very different from what we're delivering. We committed to creating a science course that would give them an experience as good or better than the one that they would have in the classroom here. And so that has come as a huge shock to a lot of students. And the things that students will often say to us are things like this. Well, the other distance ed courses that I take require me to sign in once a week and make 3 comments on a discussion post, and that's it. Very few of our students have ever taken a proctored exam as a distance education course. So the idea of doing sustained large amounts of work on a weekly basis, of doing their own experiments, is on the one hand very interesting to them because they're not getting cheated. You know, they're getting a chance to do the same science experiments that they would get if they would come to the campus. But it's also a huge shock for people who signed up thinking that this would be a way to just scrape through the science course and make up time on the semester, either by adding an extra course into their normal course load or by piling a course on top of a full-time job or childcare responsibilities or other real-life things that, frankly, are more important in the short term than the course is to them.
Right, right. Meredith, how about...
It's a lot of work for everybody.
8 other courses, I'm sure. What do you think compared, you know, online versus face-to-face?
So in terms of just pure hours, I'd say that it's pretty comparable for me from the TA perspective of teaching a normal lab course. Because, you know, for a quote-unquote normal lab, you have to spend 2 hours per section and normally do 2 sections. That's, you know, a 4-hour chunk of time you spend every week just making sure a lab happens, plus setting things up, tearing things down, you know, physically getting experiments ready and things like that. And then there's all the grading as well. Whereas this, at first glance, it actually seems like less work, but then you kind of add up all the little 5-minute bits here and there where, oh, the student had a quick question, I should probably respond. You know, oh, I was going to go to bed, but there's 3 messages about the lab, so I'll just, you know, quickly answer. So it's definitely different in terms of just time management and when you do the work. It's not a set 2-hour block on Wednesday. It's, you know, it's whenever the student gets around to it, which unfortunately is often 2 hours before the deadline on Wednesday night, or whatever the deadline may be.
Right.
And so it's really on their schedule is what I kind of have to adapt myself to some level.
Right, because I suppose
yeah.
from your point of view too, it's you have access to your email and to the computer, so it's not like you're away from your office in a way ever.
Yeah, so, I get an email on my phone and I can log into our little
so you're
Canvas, and just answer their message from my phone while I'm
accessible.
yeah. So.
And Nicole, you mentioned something interesting. Do you feel that this online course actually gives you more interaction with your students, or maybe gives your students a more interactive course experience than compared to a face-to-face course? I mean, of a similar type?
For me, the thing that really strikes me is that we're reaching students within this university's purview who otherwise would not see science. Mm-hmm. A lot of the people that sign up for this course are trying desperately to finish a degree that was begun years ago. And this is the first viable option that they've seen to do a science course via distance education and to really get the flavor of science. So in the classroom, we tend to see a lot more people who are 18 to 24 years old, fewer people with children, for example. We see more of the conventional student population. Our population is quite shifted away from that. And so it's a chance for me to connect with people who otherwise wouldn't make the connection at all. And so that is a strong motivation for us to continue to do this work, because we know we're providing a resource that otherwise would not be there for them.
And the classes always fill up. Like I think we supposedly had 30 spots this semester. In the past, it's been 25, and it fills up first thing, I believe. And then students will drop, and immediately we get new ones up until that drop date. And so it's a little chaotic, but it's definitely the demand for it as well.
Yeah, we know there's a strong demand because we offer in-course astronomy courses as well, and in April, when all the courses go on offer, this class fills in a day, and the other classes fill in 3 months. But this course, there's never an open space for long enough until someone sees it and jumps in.
Mm-hmm. Yeah, wonderful. How many years have you guys been doing the course?
So we've been teaching this as a team for 3 years in a row. This is the third year that we're doing so. We've definitely learned from the first experience, what is reasonable, what the math background of the students is, and how best to communicate with them over a distance. Something we're trying this semester that we're sort of pushing more aggressively is the use of the Google Hangouts in order to work with students through virtual office hours, as opposed to using the phone or email where you send and then you wait and send and back and forth. We're trying to see if we can really duplicate that dynamic experience where a student just walks into your office and then the questions that they come up with off the top of their head are not necessarily the questions they would have written down on a piece of paper an hour earlier.
Right. Right. So just by virtue of it being an online course, the changing technology must impact how your course looks from year to year, and so I'm sure you didn't start out doing Google Hangouts when you first started doing this. Is there any other types of technology that have come around since you started this that have either, I would imagine, helped you accomplish your goals with this course, but maybe some that have detracted as well?
Well, the big thing that kills me is I developed 14 applications that allow students to work with modern astronomical data, and I wrote all of these in Flash, because when I planned and began this project, Flash was the cutting-edge wave of the future.
Oh, okay.
That's not so true anymore, so I'm currently redesigning everything to work in HTML5 plus Canvas to ensure the maximum accessibility to the tablet and even the phone market. I don't like people working on a phone because the screen is so small, but if my choice is nothing or the phone, go with that phone. Okay. So we think hard about how to create tools that allow students to look at images and spectra and analyze data on whatever computer-based device they have available to them. And we track everything, so we can actually see the rising tide of the tablet population coming into this course.
Oh, that's amazing.
This semester, we're really seeing those devices in a way that they were not present 2 years ago or even a year ago. But we have our adherents. We have the iPhone crowd. We have the Android crowd coming in. We have the tablets. And thanks to Google Analytics, we're able to track all this so we can be responsive to exactly what students are doing.
Amazing. What a whole other type of data that you can collect on your students and from your course than you probably didn't think about way at the beginning.
One advantage is we do get a huge amount of tracking data. So we see every time someone accesses a lab exercise or runs a tool or downloads a movie from our film site, we can keep track of all these things so we know what resources are being used and when they're being used. We also partner with instructors at other institutions so we can see, oh, look, Virginia's coming online with Lab 7 this week. We know because we see the wave of students suddenly accessing these galaxy evolution tools from Virginia. So it's a way for us to track the patterns. And we can also look worldwide, and we see the people who are using our resources who have never spoken to us, people who are informally just interacting with the resources. And so we can see certain countries, predominantly English-speaking, but not always English-speaking countries, that are fastening on the resources and using them over time. And that's very interesting to me, to see the wave of the material going out.
Sure. Because this is available to anybody, is that right? Anybody?
Absolutely. We've never turned down a request for an account, and we've never charged anyone for an account. So that could be instructors who have a full class, who want accounts for every student, or just a single account in order to demo things in front of a class for a course which might not have a lab, for example. We also have individuals just from the community who want to look at things. A year ago, a medical student wrote me and said, I know nothing about astronomy and I'd love to learn. In my few hours after I work on my medical studies, can I use your system? And so we gave the guy an account, and now we see when he studies. We watch the progress that he makes.
That is wonderful. That's amazing. So I would just want to throw the website out. It's on the event page, but if you want to take a look at this, it's astronomy.nmsu.edu/GEAS. And you can look around at everything that they have there and try it out yourself. I think that's fantastic. And my background is teaching and elementary teaching, and I think I read probably on the first page of your webpage that you think pre-service teachers who often, especially elementary level pre-service teachers, often are struggling with science or are just either not familiar, not comfortable, or downright afraid or have this aversion to science. This could be something that would be a good tool for them too. Have you seen any pre-service teachers or in-service teachers using this, maybe at the K-12 or elementary level?
We have some users, and the other thing to keep in mind is that 40% of the students who take a general education astronomy course in college will become teachers in the future. Because they often take a course like this in their freshman or sophomore years, they don't always know that they're going to be education majors. But 40%, a huge fraction of the students...
I didn't know that. That's cool.
So we really are reaching out to the next generation of teachers with these college courses. And these two science courses are frequently the only exposure to doing science that teachers will have. We've partnered with a local high school, and we've tried to have them share some of our resources. Some of the lab exercises, for example, can also be conducted as just fun demonstrations and activities for younger students. Strip out all the grading and some of the more complicated questions, and then just give them the fun of doing an experiment and making plots. One of the tools we provide is a plotting resources that allow students to create histograms or X on Y plots with and without errors, and they can use this for anything. They don't have to be plotting astronomical data. We, in fact, encourage them to sort of broaden their outlook and use that tool on their own account in order to plot whatever strikes their fancy. Plot something from the political page of the newspaper if you want. Check something for yourself. Look at economic indicators. Just get active with analyzing data in a graphical form.
Yeah. And it's really quite simple. It's a text box. You type the X value and the Y value, and then if you want, you type an error and Y after that. It's really very straightforward. Or if you want a histogram, you just type a list of numbers and hit Make Histogram. So
it sounds like
it's
something
nice if they can actually see what the data looks like without having to get their hands dirty with any kind of coding or even Excel, right? Making a graph in Excel that looks decent is non-trivial. So it's nice that we have this tool for them to make graphs and immediately start seeing what the data looks like.
Oh, that's wonderful. Yeah, it's so great to have something that everybody can use and access like this. And Meredith, you talked earlier about the fun, I love the food-themed labs, the marshmallows. But you also have labs that have your students access large data sets and work with that. Is that right? And could you describe maybe one of those labs or the other types of data that you have your students access?
Sure. Nicole, give me. We haven't done one of those yet this semester, so I'm not fresh on it.
Lab 7 and 8?
Okay, sure.
Talking about the morphology of galaxies and such?
Sure. Yeah, we do have them look at at pictures of galaxies to classify them into different groups, and we also have them look at spectra of galaxies, which is a bit of a daunting topic at first, but it's toward the end of the semester, and we have them figure out, if the whole spectrum is shifted, the galaxy is moving away from us, and we can have them do a little bit of cosmology with that as well. I know it's real data they're looking at. It's not
I was
like
going to say, right.
data.
So they are accessing and working with real data, which is fantastic. And do you tell them that? Do they realize that? Because that's an
I think so. Yeah. I mean, it's not a secret.
Those students are working with data from the Sloan Digital Sky Survey, which is a large-scale worldwide program I'm sure you know of that actually has its observations conducted in New Mexico at the Apache Point Observatory. So it's very near and dear to our heart. Okay. And because all of the Sloan data goes public and is free worldwide to use, we're able to provide it to students and to let them analyze the same images and the same spectra that the professional astronomers are working with in order to understand galaxy evolution. Yeah. One thing I'd like to add to that is that for our Galaxy Lab, it's kind of a new intimidating topic, and it takes people way outside of the solar system, way outside of their comfort zone. And so the first project that we have as an icebreaker is that we show students a set of 25 galaxies, color images of them, and we just ask them to sort them. No rules, no instructions, no guidelines. We ask them, pick out what you see in these images and tell us, just like on Sesame Street, what goes together and what goes with the other group. And then we ask them to have someone else do this. And they can ask a child, a parent, another student, anyone they want. Sometimes people have a colorblind friend, and that makes it especially interesting because the color drops out and we see sensitivity to small level detail. And then we have the people sit down together after they've independently sorted these galaxies and talk about why they form the groups. You know, some people form a few groups, some people form lots of groups, some people are really focused on color, other people just care about the structure that you might see in the disk of a galaxy, and it's fascinating to see what people seize on, but it also conveys the message that there's no one right way to do this, and if you differ from that, you're wrong. But instead, that there's a tremendous amount of detail, and we all have something to contribute when we look at data like this. So we're trying to really make the field of astronomy accessible.
That's fantastic, and that's so important just in helping people understand how science works and what science is, that it's not always about having this one right answer. It's really that process of having multiple people. I mean, more and more these days, it's always groups looking at data together and trying to make some sense out of it together. And there may be lots of different interpretations and things that come out of that process. And eventually, you know, you'll come to some consensus, but it's not necessarily, you know, clear at first. So I think that's a great thing that those kinds of activities really help students learn.
It can scare them at first sometimes, I think. We show them these things and we're like, sort it, and they're like, what's the answer supposed to be? Like, do I put the big ones next to the big ones? I'm like, you tell me. The science. You get to make observations and make up your own mind and justify what you did. And they're like, oh man, I have to write a paragraph and think. All right, let's do this. So it makes them think like scientists, honestly, which is not something they would really get otherwise, I don't think.
Yeah, it absolutely does. I agree. And you mentioned before, you know, elementary teachers, sometimes this is the only type of science class that they get, and you know, honestly, with a lot of other majors as well, you know, sometimes it's this Astro 101 kind of course, or maybe it's Geology 101, or this, you know, basic level science course is all they get as far as science, and then they're off, you know, pursuing their other courses, and you know, to become citizens in the world, you know, you need to have a better handle of how science works than you know, just one shot at a course where maybe you're just trying to memorize as many facts as you can and then regurgitate it on a test and that's it. So these kinds of activities I think are fantastic. Really fun too. So tell me quickly, how do the exams work for you? Because you have your students take exams. Do they take them online? How do you set that up and make that work?
So we're quite conservative about doing the exams online because of the risk of losing the connection. And with an exam, it's kind of all the eggs in one basket. So because a large number of our students actually live within 100 miles of campus, we offer them the option of coming in live. And this is nice for us because if we school them in once or twice, they get a chance to meet us face to face. And often we see after the midterm, there's a breakthrough with certain students where after they meet us, they realize, hey, those people really want me to succeed. They're not out to get me. And communication just becomes a lot easier and frees up, and they become more comfortable. So the face-to-face exam is a nice option that we can offer because so many of our students are in the southern New Mexico area. We also have students work with proctors, so if they live at a distance or even if they live locally but have a very constrained schedule, they can arrange to work with a school teacher, a government official, a librarian, a military officer, really anyone who's in a position of authority and responsibility and is not your mother. We got to draw the line at mothers. Just someone who's in a position to sign off and say that the student worked on the exam on their own and didn't use any inappropriate resources. So far we've been able to make the proctoring system work for students all over the world. It's a bit challenging in some foreign countries because of the availability of people who are able to perform such a service, but we really think it's important. And we're actually looking this semester at doing just a couple of exams through Google Hangouts where students have an internet connection but are having trouble identifying a proctor. They're going to have the option of working face-to-face with us and taking the exam in real time.
Oh, interesting. So through a Google Hangout. So they'll do that and you'll kind of sort of watch them do the exam through the Hangout?
Yeah.
Interesting. Great idea. Very good. Okay. I wanted to quickly go back to the films that you guys are using. Is this something you guys actually did yourself? Did you go out and do or take part in doing these films?
Nicole's got a whole film team.
Yeah, so I have a great team of filmographers, and they're all graduates of the Creative Media Institute, which is a media institute here at New Mexico State University. And so what we did for a year and a half was basically wherever I went as an astronomer, they came along. So if I went to Puerto Rico and I went to the Arecibo Observatory, this huge radio telescope in the middle of Puerto Rico, they came along and we filmed. We filmed the site, we filmed me interacting with the people, we filmed the telescope. And this is a place where I had been, as a student myself and over time. So having developed a relationship with the people on site, we got a lot of access that might not have been available to a professional crew. So in a sense, we balanced our lack of money and beautiful graphics with a sort of backdoor view of astronomer's paradise. We also got a lot of help from the National Radio Astronomy Observatory, and we worked on site with their staff, and we were able to go to the very large array, and we even got clearance to go up and climb on the dishes. We had to promise nobody will fall off. But,
that'd be awesome.
We just went through the back door, and it was great fun. And I particularly enjoyed it because I discovered along the way that every single person we talked to had a story. I couldn't find a single NRAO observatory staff member who didn't care passionately about astronomy. We spent a few days with the engineers, we worked on the back end of the dishes, we talked to the librarian for 2 days, and we found out what made him care about this so much. And this is a guy who's really focused on data collection and archival processes, and he has a chemistry degree. So no astronomy in his background, but he's a critical person in the chain that connects those astronomical observations made in New Mexico and then carried throughout the rest of the world. So it's been great fun for us because we get to meet a lot of people who work in astronomy, but they're not PhDs, but they all have very interesting stories to tell, and I love hearing the stories. I love walking away from an observatory knowing more about the people there than I did when I entered the doors the first time.
I do too. I love hearing how people got really anywhere where they are, almost any career, but especially science because it's my interest too. And everybody seems to have such an interesting story, and rarely have I come across somebody who's had this direct line, somehow from being interested as a child to, becoming PhD scientist. There's often so many interesting, stops and starts and turns and things like that. It's really amazing. But through it all, like you say, it's really caring and having that passion for science or astronomy, and that kind of keeps people going. So
I'd like to mention quickly that we also have 2 films that are designed explicitly for children. So we went ahead and made a counting film to help students count from 0 to 14, as in 14 billion years, or the age of the universe. And then we have an alphabet film where we walk through the numbers and the letters, and we talk about important astronomical people and objects. And so these are short films. They're the perfect thing to read to a child if they're trying to get to sleep. And we hope that people will use those as well.
Oh, excellent. All right. So people definitely check that out also. All right, we're kind of getting to the end here, but actually we do have a comment back, Meredith, to your question about Google Docs. Lewis Hill says an idea would be to create the Google document and share it to all of the class for the assignment, and then as the owner of the document, you could lock the document at the deadline. I don't know if that helps.
Fair enough. Yeah, we usually have the students create their own document, so that might be a different way to consider doing it in the future.
Thank you, Lewis. Interesting. Good idea.
Yeah.
Great. So I want to give you guys just, I guess, the last couple of minutes here to give us any last thoughts that you want everybody to know about the GIAS project. And we'll get the links and everything out there again. I'll have some more information posted on the event page after this, so people can come back and look there. But Meredith, do you want to start? Any last thing about how it's maybe impacted you personally, or anything you want to share?
Sure. I think for me, getting to work with Nicole on this project has been really eye-opening, because I previously TA'd at San Diego State University when I was getting my master's degree, just in a normal classroom environment, and not as many of those students face the same challenges that we discussed as some of the students that we have now in our distance class. And so I think it's really great that we've been able to develop this resource that meets a need here in New Mexico for sure, but that as we continue to refine and tweak little pieces of it, it's really something that can be adapted on a larger scale by pretty much anyone who wants to. And I think a lot of the future of astronomy education, like it or not, is going to be online, or at least largely online, and that getting students actually to do hands-on experiments is one of the best ways to understand science. So I'm really glad I get to be a part of this whole effort. It's been really cool.
That's wonderful. Thanks. And you know, give yourself a quick commercial, Meredith. I know you you tweet and you do a blog, and Nicole had shared. I know you've written a couple articles about, or maybe it was just one article about the GIAS project.
Yeah, I wrote an article that was published on the Astronomy magazine, right, on their blog, and I also wrote it on my own blog, which is Astronomers. So if you take my little Twitter username that you can see on the bottom of my name there, and you just put Astrono in front of it, .wordpress.com, that's a blog I've started recently that I'm trying to write about, basically explaining different astronomy concepts to in a level that anyone can understand and find interesting. It's a relatively new thing I've started, but I also do tweet, so feel free to follow me on Twitter if you're so inclined. Yeah.
Okay, excellent, thank you. And then Nicole, any last thoughts you want to leave with us about your project here?
I'd like to really appeal to anyone who is interested in the project to contact us. We're actively looking for beta testers, for instructors who'd like to work with their classes on both our lab exercises and the self-review library. So particularly people who are in a position where they're not supported in their own position to develop their own resources, we want to make your life easier for you, and we want to extend the reach of astronomy. Also, our film programs come with discussion guides, so if you're an elementary school teacher or a high school teacher and you think this would be an interesting thing to present in your classroom, we provide a guide as a kickstart to have a discussion going, and we have questions both appropriate for older children and for the younger children who can get a lot out of these materials. Everything's G-rated, no worries there. And even, you know, if there are people who are homeschooling children out there who are getting nervous about the math and the science issues as the students become older, that's another type of student that we're interested in interacting with. But we've been working with instructors in California, New Mexico, Virginia, and we're also talking in Connecticut and Arizona and even Canada. Okay, don't tell the federal government, but we're even letting the foreigners work with the tools.
Oh, okay.
We really are committed to having people use these resources. We don't want to be in a position where students have to pay $100 or $150 to a commercial company in order to get access to this sort of thing, if we can provide it from within the astronomical community itself. So we'd really like to free up the access to astronomy.
Okay, that's wonderful. A great program. Again, it's astronomy.nmsu.edu/GEAS. I want to thank both of you for being on the show. This is just fantastic. So Meredith Rawls, Nicole Vogt.
Thank you so much for having us. It's a great opportunity for us to talk about the project.
Oh, yes, thanks very much.
Okay, well, really enjoyed it. So this has been Learning Space, and we'll be back again next week at Wednesday, and Nicole Gugliucci will be back with me next week. So yay, Nicole. She's coming back. Our next hangout here at CosmoQuest is the weekly space roundup, which is Friday at noon Pacific, 2 p.m. Central Daylight Time. So we hope you all come back and spend some time with us then on Friday. Thanks again, and we'll see you guys all next week. Goodbye.
Goodbye. Cornell, just as this telescope time was all available, and nobody knew what to do with it. So it was a wonderful time to get involved in a large-scale survey, which is something that I did with Martha Haynes there. And then when I started being a postdoc, the Keck telescopes were really coming into their glory. So I jumped into the UC system and started observing a lot of Keck. So in a sense, rather than moving from university to university, I jumped from telescope to telescope.
Excellent. It sounds so bizarre to have lots of telescope time and nobody knows what to do with it.
Yeah, that was a very brief one.
Great. Okay, thanks. Meredith, how about you? Tell us a little bit about yourself and your current interests and what you're doing.
Sure. So I'm a graduate student here at New Mexico State University. I just began my fourth year, I guess it is now. And my main research interest is actually a little different than Nicole's. It's more about stars, and in particular binary stars, or stars that come in pairs. And I got mostly involved with that research a little bit in undergraduate. I went to Harvey Mudd College for my undergraduate. But it really kind of became the direction I was heading when I was at San Diego State getting my master's degree, because my advisor there worked on a really cool kind of binary star called an X-ray binary, where they put out these crazy X-rays, and you can figure out all kinds of interesting things about the two stars by observing them in different kinds of light. So while I haven't really stuck with X-ray binaries per se, currently, that kind of got my interest really in these crazy stars that orbit around each other, kind of going from there. So.
Okay, fantastic. So you're a grad student there, and so you, so both of you are involved in teaching at the university, and Nicole. Okay, are we all here? Meredith and Nicole, try to unmute yourself, if you would.
Alrighty, hello.
Top, that's okay. You're good? Is that, and Nicole? Let's see. Okay, Nicole, try up at the top.
How about now?
There you go.
There you are.
Excellent.
So I had two people? Excellent. Okay. All right. Hi, everybody. This is Learning Space, CosmoQuest's weekly hangout about astronomy education and outreach. And I am Georgia Bracey. I do formal education with CosmoQuest. And today I'm very happy to have with me two wonderful guests, both from the University of New Mexico. I have Meredith Rawls, and I also have Dr. Nicole Vogt, if I've said that right. And we'll have you guys tell everybody a little bit about yourselves in just a second. I want to tell everybody out there that you can watch this video on our YouTube channel. You can also look at the CosmoQuest event page and watch us there. You can also comment in both of those places. And you can also comment on Twitter with the hashtag #LearningsSpace. And I will do my very best today to try to track people's comments and respond, pass along questions. So please feel free to ask us questions as we go. make some comments. We have a great program today. We've got a wonderful astronomy learning tool that everybody can take advantage of, so we want to share all that out with you today. So enjoy the show with me today. So let's start with Nicole and Meredith. Nicole, would you like to start? Tell us a little bit about yourself, just briefly, and what your research interests are at the University of New Mexico.
So I'm a member of the extragalactic group at New Mexico State University, which means that I study things beyond our own galaxy, and my focus area is studying the evolution and the formation of galaxies. Oh. So in a nutshell, what I need to do is to understand how stars change and grow over time within galaxies and thus affect the evolution of the galaxies themselves.
Okay, wonderful, wonderful. How did you get interested in that area?
Well, I've always thought extragalactic astronomy was just a heck of a lot more exciting than other fields in astronomy. No offense intended.
I know, it's fascinating. I have to agree.
A lot of other things seem like work, but
really wild stuff.
This was the fun part. I sort of followed telescopes my whole life. When I was a child, I had a chance to go to Palomar Observatory when I was very young, and the weather was so bad that the astronomers on site weren't able to observe. So what we did was we basically grabbed huge pieces of paper, and then we shone the light through the telescope onto a wall, and we went ahead and looked at the moon because they weren't working anyway. So it was a really fun adventure for me as a child, and a way to see exactly how telescopes worked.
That's
and
great.
Then when I graduated from college, Cornell University had just bought a large share of time on the Palomar 5-meter telescope, which at the time was the largest optical telescope in the world. So I landed at